Today I am going to explain you about a condition for distortionless line. First of all, we'll see what do you mean by distortion. Distortion means if the output is not exact replica of your input signal, then we can say that line is a distorted line. In general, we'll see 2 to 3 types of distortions. So one is distortion due to characteristic impedance, another distortion is due to a frequency, nothing but a frequency distortion, and third one is due to a phase constant, nothing but phase distortion. So here, to make the transmission line as a distortionless line, here we have to consider the two distortions. One is frequency distortion and phase distortion. In this frequency distortion, we have to make the attenuation constant which is independent of frequency, and the phase distortion, phase constant, is dependent upon the frequency. If we make the two conditions, if the attenuation constant is independent of frequency, phase constant is dependent upon frequency, then we can say that line is a distortionless line. Here we have to consider the one more condition. One is R by L is equal to G by C. Okay, now we will see this derivation. So for that purpose I am considering a one transmission line, and we know that this transmission line is in two parallel wire lines which has a series resistance with a series inductance with a shunt conductance and shunt capacitance. So to derive these two conditions, I am considering the propagation constant gamma, and we know that the propagation constant gamma is equal to under root of Z into Y. Here Z is nothing but your series impedance, Y is nothing but your shunt admittance. I know that we are saying a series impedance means its value is nothing but R plus J omega L. The shunt admittance is G plus J omega C. So therefore gamma is equal to, we know now, it is a propagation constant, so which is equal to your attenuation constant with a phase constant. Alpha plus J beta is equal to, multiply these two terms, or simply take down the R and G terms common here. So in this one we will get, I am taking the R and G terms as common. So I am taking the R term as common. So from here, so 1 plus J omega L by R, here G by G into 1 plus J omega C by G. So multiply these two terms, R into G. So remaining rest are 1 plus J omega L by R into 1 plus J omega C by G. And here we are assuming now, so let us assume that L by R is equal to C by G. So this is from R by L is equal to G by C, or L by R is equal to C by G here, from here. So I am simply substituting these values in this one. So I am getting gamma alpha plus J beta is equal to RG into 1 plus J omega L by R. Substituting anything, here it is L by R as a C by G. So you will get a square term here. So it is under root of RG into 1 plus J omega C by G. So now multiply these terms. So under root of RG plus J omega into under root of RG into C by G. Here I am writing this term as a under root of R into under root of G, and C by G as a under root of G into under root of G. Cancel out these terms. So here I am getting alpha plus J beta is equal to under root of RG plus J omega, this term C into under root of R by G. So but we know that this is the basic condition, R by L is equal to G by C. So can I write R by G as a L by C? So R by G is nothing but L by C. Substitute R by G as L by C here. Simply I am substituting here R by G as L by C. So here I am getting under root of RG plus J omega, C as under root of C into under root of C into under root of L by under root of C. One root term will get cancelled. So here we will get J omega into under root of LC. Therefore the alpha plus J beta is equal to under root of RG plus J omega into under root of LC. So comparing these real terms, here we will get alpha is equal to under root of RG. Here alpha is what? Attenuation constant. So here we have to derive the one condition, that alpha which is free from the frequency. Okay, similarly compare to these imaginary terms, beta is equal to J omega into root LC. So beta is nothing but omega into root LC. And we are taking the one more condition, beta or phase constant which is independent on frequency. Then if alpha is independent of frequency, if beta is dependent on frequency, then we can say that line is a distortionless line. Okay, hope you got it. Thank you.